Alright, in this video I wanted to walk through some examples that you guys might see on worksheets or really anywhere with exponents, okay? Now, just a disclaimer, these problems that you guys are going to see look a lot more intimidating than they actually are, okay? So if you see something like any of these problems that I'm going to go through, please just take a deep breath because it's not as bad as you think, okay? So here's one, for example. I'm going to do 5k to the third power times d to the fifth power, and I'm multiplying that quantity by 4k to the fourth power d to the sixth power. What's important to remember is that every single term in this problem is being multiplied together, right? The 5 is being multiplied by k to the third power, which is being multiplied by d to the fifth power, right? It's only multiplication that's happening between all of these things here. So if it helps you to rewrite the problem like this, so that way it's not as intimidating, please by all means do so. We know what 5 times 4 is, so this is 20, right? We know, we have k to the third power times k to the fourth power. Hey, does that sound like one of our rules? Yes, it does. It looks like we're going to have a product with the same base. So, what do? Oh, well, it's a good thing I wrote some notes about this. Product with the same base. Oh yeah, we just add the exponents together. So, k to the third times k to the fourth is k to the 3 plus 4. So, k to the 3 plus 4, that equals k to the 7th. So I'm going to go ahead and write that. Then I'm going to do the same thing with d. So d to the 5th, d to the 6th, hey, they have the same base, so that means I can use my rule here. So d to the 5 plus 6 power, that's d to the 11th. And this is my final answer. See how that works? Let's try another one. What if I have something like this? I have 2r cubed times 5r to the 6th n to the 4th. Remember, all of this is just multiplication. 2 times r cubed times 5 times r to the 6th times n to the 4th. And because multiplication is commutative, we can really do anything we want here. So I know that 2 times 5 is 10. R to the third times r to the 6th is the same thing as r to the 3 plus 6th power, which equals r to the 9th power. So, right, those two bases are the same. I don't have anything else I can combine, but we can't leave out n to the 4th, so we just tack it on to the end. And that's our answer. I want to take a look. Maybe there's some negative exponents here. Ooh, yes. All right. 6d squared times 8d to the negative 2 power. So I know that, well, I guess let me rewrite this. So 6 times d squared times 8 times d to the negative second power. Well, the d's are the same base, so that means I can use my rule here. So d squared times d to the negative second power is the same thing as d to the 2 plus negative 2 power, which we know is 0. So d to the 0 power, and anything raised to the 0 power is just 1. So 6 times 8 is 48. 48 times d to the 0, or 1, is just 48. That's my answer. Okay, let's do some quotient problems. I think that would be fun. Let's see. Okay, so remember my disclaimer. These look a lot more intimidating than they actually are. Okay? So, let's take a look. 7 GR to the negative fourth power. So remember, r is raised to the negative fourth power, not gr. There's no parentheses around that. All right, and then we have 6g to the negative second power, and then r to the fourth power. Okay, let's break this apart. So I'm going to split this into 7/6 times g over g to the negative second times r to the negative fourth over r to the fourth. You can split apart a problem like this just like this. Okay, because what's happening is there's a bunch of multiplication in the numerator, a bunch of multiplication in the denominator, and hey, if we split it and multiply all those things together, we get the same thing. So now we have a bunch of things we can work with. Here, I can rewrite g as g to the 1. So remember, if you have a division problem with the same base, which we do, right, we have g's here, all I do is subtract my exponents. So this is g to the 1 minus negative 2 power, which we know is g to the third power. And that is going to be in my numerator. Okay? Let's do r. So we have r to the negative 4 minus 4. And we know this is r to the negative 8. So let's rewrite what we have. I have this, I have this, and I have this. So I have 7/6 times g to the third power times r to the negative 8th power. But we don't like negative exponents in our answers. So I'm going to rewrite this. And I can include the g to the third power in my numerator. 6. Remember, with negative exponents, this, here, let me switch colors here. This r to the negative 8 becomes 1 over r to the 8th power. So really, it's like taking this and dropping it into the denominator here. So my final answer is 7g cubed over 6 times r to the 8th power. And there you have it. Let me see. That was number 1. Okay. Let's try another one. Now, the reason why they look intimidating is mainly because it's a bunch of exponent problems packed into one, right? You're probably looking at the examples that I did, and you're like, whoa, that looks nothing like what we did. Yes, it's true, but because, like I said, with the problems that I'm doing right now, you'll notice that there are a bunch of steps involved. So these are kind of like our multiple step equations. There are a lot of steps you have to take in order to find the solution. And that's all you're doing. So it's a matter of recognizing what properties you can use to help you simplify the answer. So with that, let's take a look at another example. Let's take a look at, so 9hy cubed over 4h to the 5th y to the 4th. So remember, I can split this, and I believe this is page 19. I can split this to look something like this. So 9 over 4 times h over h to the 5th times y to the 3rd times y to the 4th. So I always include this step because this right here that I'm putting a box around, this right here helps you visualize all the different things that you need to do, right? I did it with the multiplication too. I rewrote it. Here. No! Sorry. I rewrote it. I rewrote the original problem so that way I could see all the individual parts, right? I could see the r's, I could see the n's, I could see the whole numbers that I'm multiplying, and that really helps. Make it easier to process. Okay, so I highly encourage that you guys do this. So let's take a look. Let's solve each of the different parts. 9 over 4. I'm just going to leave it like that. Okay, h divided by h to the 5th power. That's like saying h to the 1 divided by h to the 5th power. And I know with division, I just subtract my exponents. So 1 minus 5. So this is simplified to h to the negative 4th power. Let's simplify the y's. So the same thing, it's a division problem. So I'm going to subtract my exponents, 3 minus 4. So now I have y to the negative 1 power. Now I have all of my parts simplified. So I'm going to rewrite it up here. So 9, h to the negative 4, y to the negative 1, over 4. Now with negative exponents, we don't like them in our answer. So what I said earlier, right, I'll use a different color here, h to the negative 4 we know is 1 over h to the 4th, and then y to the negative 1 is the same thing as 1 over y. So really, it's kind of like taking this value and dropping it to the numerator, or to the denominator, excuse me. So my answer is no longer that, but now we have 4. We dropped the h to the 4th power, or we flipped it, so now it's 4 times h to the 4th power, and then we dropped the y as well, and there we go. That's our final answer. Okay, so hopefully this is making a little bit more sense. Again, I'm gonna keep saying this because the problems do look intimidating, but if you break them apart, just like I did, you will be able to solve them with ease. Okay, so there's one more type of question that I want to go over really quick. Okay, and that would be our power rule. So let's take a look. Let's start off a little simpler. I mean, there's a little bit involved here. Okay, so I have d to the 6th power divided by d to the 3rd power, and all of that raised to the 2nd power. Now, thinking about my power rule here. Right, when I raise a value to another power, I can just multiply my exponents together. Oops, went too far. But what's important is that you're raising, so let me rewrite this. So this is kind of like saying d to the 6th raised to the 2nd power over d to the 3rd raised to the 2nd power. So it's almost like it's kind of like I'm distributing that 2, but it's not distributing, we're actually raising the power to the 2. So that's one way you could solve it. Or you could solve it this way. You could solve whatever's in the parentheses first, right? And then raise it to the 2nd power. We know that d to the 6th divided by d to the 3rd is the same as d to the 6 minus 3 power. So you get d to the 3rd, and then that's raised to the 2nd power. So it's kind of a whatever floats your boat problem here. So d to the 6th raised to the 2nd power, well, we multiply 6 and 2, So that's d to the 12th. Sorry, I'm jumping back and forth here. So I'm going to solve this top problem first. And then in the denominator, I have d to the third raised to the second power. I multiply those two together, so I have d to the 6th. Now I have d to the 12th power divided by d to the 6th, which is the same as d to the 12 minus 6 power, which is the same thing as d to the 6th. Let's see if I get the same answer here. Well, I have d to the third raised to the second power. I multiply this 3 and 2, and now I'm at d to the 6th power. And look at that. So it's up to you how you want to solve this problem. There are different ways you could solve it, okay? But all I ask is that you're careful, right? And you check your work, and you make sure you're following the rules that are set, okay? Let's do one more. Let's do one more of these power rules here. Okay, let's do a little bit more of a challenging one. So I have 2c squared all over 3c to the 5th h to the 4th, and that is all raised to the second power. Ooh. Okay, so for me personally, I like to solve whatever is in the parentheses first before I raise anything to exponents, just because it makes my life a little bit easier, okay? So I'm going to rewrite what's in the parentheses. So this is 2 over 3 times c squared over c to the 5th times 1 over h to the 4th. Okay, and I know that all of that is raised to the second power. So let's see what I can solve in here. I believe I can solve this section because my bases are the same. So let's see. This is the same thing as c to the 2 minus 5 power. So that is c to the negative third. So let me rewrite it. So I have 2 in the numerator, c to the negative third, and then 1 in the numerator, but I don't need to write it. So now I have 3 in the denominator, and just h to the 4th in the denominator. And that is all raised to the second power. Now what I can do is square everything. So I'm going to move back up here. So I can go 2 to the second power times c to the negative 3 to the second power over 3 to the second power times h to the 4th times the second power. And now we just simplify. So moving along, 2 to the second power is 4. C to the negative 3 raised to the second power, we just multiply those two together. Multiply the two exponents together. So now I'm at c to the negative 6th over 3 to the second power, which is 9. H to the 4th raised to the second power. So I multiply my exponents together. 4 times 2 is 8, so I have h to the 8th power. Now, we don't like negative exponents, so using the negative exponent rule, it's like we are dropping this from the numerator to the denominator. So my final answer is 4 over 9 c to the 6th h to the 8th power. Yep, and there we go. All right, folks. Well, I hope that you guys are able to break these problems apart, so that way they're easier to process. Okay, that's really all these problems are. They're just multiple problems wrapped up into one. Okay, so again, let me know if you have any questions. Come see me during office hours, or just send me an email. All right, you guys, hang in there, and I will see you in the next lesson.